In 2004, Breault Research submitted a Phase 1 proposal through the Navy SBIR program for a solid-state light solution to replace the legacy deck lamps that currently exist on Navy ships. Our proposal was accepted, and we did an initial design, conceptual design, that looked favorable. We then made a prototype in the Phase 1 project, demonstrated it to the Navy, and it was well received. Several years later, we received an invitation to submit a Phase 2 proposal, which was accepted. And then over the next 3 years, designed, developed, and built 2 prototype Navy deck lamps. Our design approach was to divide the deck lamp optical system into different subsystems. One illuminated the far field, one the midfield, and another subsection illuminated the near field around the deck lamp. This allowed the most efficient interchanging or interlocking of illuminants between adjacent deck lamps, which minimized and tried to remove a lot of the shading and shadowing that occurs between adjacent deck lamps. Our new deck lamp design uses solid-state devices, which give better electrical efficiency, lower power consumption per deck lamp. They also provide a greater output luminous intensity, which provides better visual acuity for deck crews to identify foreign object debris, which is a safety hazard for both deck crews and equipment during flight operations. At the beginning of our project, we developed a set of requirements with the Navy. To fit within our budget, we really looked specifically on what could be done and the amount of time that we had available.
My involvement on the Navy deck lamp project started in the middle of the Phase 1 contract, where we finished the preliminary design ahead of schedule and under budget, so we were able to produce a proof of concept during the Phase 1 contract, so that at the end we not only did the design, but we had a way to demonstrate that the design had merit. During the Phase 2 of this contract, then my involvement was to get the system ready for fabrication, essentially. We went ahead and redesigned the optics so that it would include all the features that we needed, and then had those parts made for us. And we did that for a couple of pieces that go into the system. The collimating optics that go in the bottom row of the lamp, and also the Fresnel lens that is used to get the distribution that we need on the deck. We modified the design to make it more easy to manufacture.
Not only did we have to consider the illumination requirements, but also the volume for the electrical systems, the volume for the optical systems, and also the environmental conditions, such as the extreme high temperatures, low temperature environment, the salt environment from the oceans that the ships obviously operate in, and EMI requirements, electromagnetic interference. All these requirements we had to really learn and be able to design a system that would survive in that environment, not just initially, but also for the long term. And so that was our own personal goal that we really tried to achieve in our design process. Our long-term business goal is obviously to be able to go through the entire development cycle with our Navy customer. But in addition, we want to look at commercial markets and leverage the technology that we've used in developing the Navy deck lamp for architecture lighting, which solid-state lighting can provide capabilities that far exceed incandescent and other standard lighting systems that are used today. Customers are coming to us today really focused on green technology. They have legacy illumination systems that they want to replace their incandescent bulbs, incandescent lights with solid-state LEDs. Breault's knowledge of the system issues, illumination, mechanical, packaging, electrical, and the environment, we can really provide those customers with a system solution which will meet their requirements.